This is number 22. Pay attention. This question is so controversial, but I'm going to teach you how to get the tricks to unraveling the answer. Now, it says, which of the following equations could be used to represent the standard enthalpy of formation of glucose? Standard enthalpy of formation of glucose, which of these equations can be used to represent it? Now, these are the equations. Which of them have the reactants and products in their standard states? That is indirectly what the question is saying. Here says carbon atom, solid, plus hydrogen gas, plus oxygen gas. In fact, there are many possibilities towards the production of glucose. Look at the possibilities. Glucose, C6H12O6. There are many possible ways of arriving at glucose. You can say carbon atom plus hydrogen atom plus oxygen atom gives you glucose, C6H12O6, meaning 6 carbon atoms at the product side, you write 6 at the back, 12 hydrogen and 6 oxygen. But for this to be true, for this equation to be true, all these atoms must be gases. Gases. They must be gases. They must be gases for it to be true. You can say carbon atom, gas, plus water, liquid, to afford glucose. You write 6 here to balance it. It is true, because all these species are in their standard states, and glucose is also in its standard state. What other possibility? You can say carbon atom plus hydrogen gas plus oxygen gas to give you glucose, O6. Now, carbon atom must be gaseous. Hydrogen, gas. Oxygen, gas. To balance the equation, carbon is 6 here, you write 6 at the back. Hydrogen is 12, you write 6. Oxygen is 6, you write 3. Balanced. You write 3. So, it's balanced too. But, look at the rule. Look at the rule. The rule is that atoms must be gases. Atom must be gas at standard state. Molecules or compounds must be either gas or liquid or solid at standard state. Now, let's check the options again. Let's check the options. In the A option, carbon is an atom, C, symbol of the element, and it's a solid instead of gas. Therefore, this is not the answer. Carbon 4 oxide in standard state is a gas, correct? Water in standard state is a liquid, correct? Glucose in standard state is a solid. Glucose powder is a solid, correct? Oxygen in standard state is a gas. So, option B is the correct option. B is the correct option. Now let's check C. Carbon in standard state, gas. Hydrogen, H2 in standard state, gas. Oxygen, gas. Glucose, solid. Carbon, gas. Hydrogen, gas. Oxygen, gas. Glucose, solid. C seems to be correct too. Yes, because all these species are in their standard conditions. D is not correct. Glucose should be in solid form and not aqueous. Now let's reconsider these two. These two seem to be correct, but check it out. Carbon atom cannot exist without being in combined form or without being in a crystalline form like amorphous, diamond and graphite. But this carbon atom is gaseous. If you check this carbon and check this oxygen, it is more logical to say that this carbon and oxygen combine to form carbon dioxide, which is a real molecule. So B is realer than C, because C plus O2 can easily give you CO2, which is a real molecule. And not only that, B option is very correct, because glucose in nature is actually formed through photosynthesis, where carbon dioxide combines with water in a plant's body to form glucose and oxygen as a byproduct. So B is more correct because it's more natural and all the species are in their standard states.